Hey folks, welcome to my channel number pin. So there we have the problem on the screen. Integrate the following with respect to x. We have x secant x tan x. So what we've been given is dy by dx and we've been asked to find y. So my y is nothing but integral of the given expression. So let's write down what is our y. So that's my y. I know that my y is not in a very simple format whose antiderivative I know from first principles. Therefore, can I solve this by any of the methods I know so far? Method 1, integration by substitution. Am I in a position to connect one expression with any of the other two expressions inside the integral, right? So I have a x, I have a secant x, I have a tan x, right? I have three parts to my integral here. The answer is no, I'm not able to connect any of these expressions with each other in any form. So, can I solve this by the method of integration by parts? The answer is yes, because I do see that if I treat my x separately and treat my secant x tan x dx separately, I see that I have an expression of the format integral of u dv, right? Therefore, I'm going to apply integration by parts and try and solve this problem. And let's see what happens, right? So, my integration by parts, what does it say? Integral of u dv equals uv minus integral of v du, right? So, there we are. So, now the key to solving this problem is, choosing the right u and v, right? And we have x and we have secant x tan x dx. I know that my d by dx of secant x is secant x tan x dx, right? So I have two options here. I can choose u equals x or u equals secant x tan x, right? So I'm going to go ahead and solve this problem choosing my u equals x, right? So if my u equals x, what is my dv? My dv is secant x tan x dx, right? Now I have my u, I have my dv. Can I figure out what is my du? The answer is yes, my du is dx. And from my dv, can I figure out my v? The answer is yes. Answer is secant x. I'm going to reserve my constants towards the end. So I have my u, I have my v, I have my dv, I have my du. So can I go back to my integral by parts and my integral of x secant x tan x dx becomes equal to uv, which is nothing but x secant x minus integral of v du. My v is secant x and my du is dx, right? So I have my integral of x secant x tan x dx equal to x secant x minus integral of secant x dx, right? Now, do I know the integral of secant x dx? The answer is yes. We have solved it earlier by the method of substitution. So I'm not going to solve it again, and I request you to take a look at my video where I've solved for integral of secant x dx. I'll put a link to that particular video in the description as well. So let's go and express our final answer. We more or less arrived at what we want. X secant x minus of log of mod of secant x plus tan x. And then I have my constant plus c, not to forget my constant. So there we are. I'm going to spend the next few minutes helping you understand why did I not go with the other substitution, right? So let's take a minute to go back to the substitution of u and dv, and we will spend a few minutes here, right? Now assume I had used the other substitution which is possible, right? Which is u equals secant x tan x and my dv equals dx, right? Which means my du by dx is nothing but d by dx of secant x tan x, right? So arrive at my du, I will have to differentiate secant x tan x applying the product rule of differentiation, right? Now, where does it take us? It takes us to a much complicated expression here. My V, of course, is quite simple. Now you understand why I went by the other substitution, right? And the more and more you practice, you will understand what is the better UV combination for a particular problem. Until then, you can try out both the substitutions and see which one works for you, right? So, therefore, we did not go with the other substitution because the other substitution would have made our solution to the problem very complex. It would have taken us a lot more time to solve this particular problem, right? So, there we are. I hope you found my video useful. Please do subscribe to my channel and support.